Video 5. The fifth connective. Fifth one. First one negation. Second one conjunction. Third one disjunction. Fourth one conditional. Fifth one biconditional. Biconditional. So biconditional we write P, two statements, P biconditional Q. So that is P if and only if Q. P if and only if Q. Or sometimes we use this for if and only if we will write IFF. IFF means if and only if. Both ways it should P conditional Q and Q conditional P. If both are there, we say biconditional P, biconditional Q. Note P biconditional Q is equivalent to P conditional Q and Q conditional P. Both must be true. So if and only if statement. Right? If and only if statement. The truth value of truth table for P biconditional Q. Truth table for, so this is P, this is Q. P if P then Q. Q then P. Then P biconditional Q. So now these are the things. We have TT or TF, FT, FF. Conditional Q. That is, P conditional Q is false only when T is, this is true and this is false. So that is happening here. It is only F here. Rest of them are all T. And Q conditional P means this is false only when Q is true and P is false. Q is true and P is false. Q is true here. Q is true and P is false is here, the third one. So third alone is false. Rest of them we can write true. Rest of them we can write true. Now biconditional means P and this and this. We have to take and for these two. And means, if both of them are true, then only you will get true. Here both are true, so you will get true. If one of them is false, it is false. If it is false. So therefore, the truth table for P, if and only if Q is true, false, false, true. That is, when if both are true, then the biconditional is true. Look, both are false, biconditional is true. Otherwise, it is true. If both of P and Q, if both of P and Q are true or false, both of them true or false, then P conditional Q is true. Otherwise, both are true or both are false, then this is true. Otherwise, P biconditional Q is false. That is, if one is true and the other one is false, the biconditional statement is false. Right? So this one. So this is biconditional. right? Now we will start with logical equivalence. Logical equivalence. Logical equivalence. Logical equivalence. So tautology. First we see what is tautology. Tautology. A compound statement that is always true. A compound statement which is always true, irrespective of the truth values of the irrespective of the truth values of the propositions occurring in it, of the propositions occurring in it. Compound statement is called, the compound statement is called a tautology. A tautology. Similarly, another one, contradiction. Contradiction. A compound statement which is always false, the always true here, always false, irrespective of so I will have to repeat something. Logical equivalence, that is heading. Tautology means a compound statement is called a tautology if its truth value is always true, irrespective of the truth values of the propositions occurring in it. Contradiction is a compound statement which is always false, irrespective of the truth values of the propositions, occurring in it is called a contradiction. Is called a contradiction. Now we will come to the definition of logical equivalence. Two propositions or statements P and Q are logically equivalent if P biconditional Q is a tautology. So in this case we write, P is logically this symbol we use, or we use this symbol P, this one. P implies double horizontal line. P implies Q and Q implies P. That is, P and Q are logically equivalent, or sometimes we also write P equal to Q. So two propositions are logically equivalent if the biconditional statement is a tautology. Now we will problems using truth table using truth tables prove that one P conditional Q is equivalent logic negation P or Q. Okay. 2 P and Q and negation P or Q is a contradiction. Solution. Now we'll prove the first one. First one is P conditional Q is logically equivalent to negation P or Q. So we have P, Q, and then P conditional Q, and then negation P. Next one, negation P or Q. Negation P or Q. Here we have TT. So P conditional Q, TF, FT, FF. Now you see P conditional Q is false only when P is true and Q is false. Otherwise it is only TT. Negation P is opposite of P. True becomes false. True is false. True. Opposite of P. Negation P or Q. Negation P is here, Q is here. We have to take or between. Or between means one of them is true, it is true. Both are false, it is false. One of them is true, so it is true. One of them is true, it is true. Now we can see that the column corresponding to P conditional Q and negation P conditional Q are equivalent. T, F, T, T. Here also T, F, T, T. Therefore, columns representing these two are identical. Columns representing P conditional Q and negation P or Q are identical. Therefore, P conditional Q is identically equal to negation P or Q. So this is a very important result. If P, then Q is equivalent to negation P or Q. So this completes problem number 1. Then we will go to problem number 2 in the next video. This completes video 5.